just a quick one today, how to go through the testing of Contactor. The same rule applies for all different kinds of Contactor, whether it's 24 volt DC, 230, etc, etc. They're all the same to test. So usually it depends on the fault, obviously, but if you just want to go through the whole test of a contactor, I'll show you that today. So first kind of fault would be if the contactor's not pulling in. So if the contactor should be on and it isn't, the first thing you're going to do is check the coil. To do that, use your multimeter. You want to test the resistance, so we're going to go to the ohms. Now the issue that you have, unless you have a brand new contactor to reference against, you're kind of not gonna know exactly what resistance it should be. If you're looking for some outliers, so if there's no resistance at all, say like now there's very low resistance or extremely high resistance, you'll kind of understand that there's an issue there. So if we test this, I'm going to go across A1 and A2, which is the coil. You're just going to check your resistance across those two, and so I'm just going across A1 and A2. So that is reading at 1.5 kilo ohm, which is about right. From experience, that's no problem at all on this coil. And so that's one kind of test that you can do, and obviously if you say, like I say, if there's something extremely high, extremely low, something that stands out, then there could be an issue. Better than that, if you've got another one of these lying around that's brand new, you can check it against that and check the resistance are kind of similar. They don't have to be exactly the same, but somewhere in the ballpark, as long as they're similar. So that's one fault. Now say another fault, an example would be the contactor is pulling in, but the motor's missing a phase or something's not right. In that case, we can test the three phases. So you've got line L1, L2, L3, and then you've got the tails at the bottom. So tail T1, T2, T3. So the first check is continuity. So you go to continuity tab, always check, you can hear that noise, always check that your meter's working for continuity. So what I'm going to do is go across these two. Now, contactors, this contactor and 99.9% of contactors are all normally open. And what that means is in its natural state, so when the coil is not energized, it means that the switch is open, which means that there's no current flowing through it. Now, each one of these should be closed. So what I normally do is just kind of quickly just check through them all, make sure that each one is definitely open line across those. Yeah, so all of them are all open line. Now the next thing to check is when you energize it, and we can manually press it, you see there, and that's got quite a low resistance, and that means that there's continuity. So if we make a note of that there, that was quite a low resistance there. It's like, make a note of that in your head just quickly, and as you flick through, just because you've got continuity, you want to be checking the ohms resistance as well, making sure they're all very similar. And what we're looking for is low resistance, because it's obviously open, and current is being allowed to pass through by the switch. So that's great. So they're all you've got continuity, they're all relatively low resistance, which is great. Now this contactor's got an auxiliary on it, which is this is a normally open auxiliary. So you have two types of auxiliaries on contactors. You've got normally open, you've got normally closed. This one has only got normally open, so it's probably not the best one to show, but normally open, as we said earlier in the video, when you put your leads across it, open line, there's no current is being allowed to pass through. Normally closed is the opposite, so in its natural state, current is allowed to pass through, and when the contactor is energized, it cuts it, it stops the current flowing. So what we do is this exact same test on this normally open, and what we do is we go across and we just kind of try and keep my hands out of the way a little bit, but we just check that there's continuity and check that it's low enough as well, so that's around the same. If it was normally closed on here, you would just do the same thing, but obviously a lot of times it can catch apprentices out and things like that, so what you want to do is make sure that you understand the difference between the two, and when you're testing it, you understand the difference between the two, because some people think, oh well, you know, there's energy flow and there shouldn't be, but it's normally closed. So getting your head around that first is a good idea. But so that contactor is fine. It is a kind of it's a used contactor, had lying around for a while, but it is okay. And yeah, hope you enjoy the video.